Well, alright, in this video I'm going to use some different formulas that are prevalent in trigonometry in order to solve a problem like this. We have cosine of 7 pi over 12 and I want to evaluate that. I want to figure out what the answer is there. In other words, what's the x-coordinate at that angle, 7 pi over 12. So, in the beginning of trigonometry, we simply graphed the sine wave and the cosine wave and tangent, and we actually did a little activity where sometimes sine and cosine actually look almost exactly the same, they're just shifted a little bit differently. And mathematicians discovered that there were a lot of these identities that showed up, and some of these identities show up in the way of a sum and difference formula. So these are the sum and difference formulas for sine, cosine, and tangent. So this one says that sine of A plus or minus B equals something. So it's an identity because there's this equals. These two are equivalent. So I've got a sine of an angle plus another angle. That's going to be the same as saying sine of the first angle times cosine of the second angle plus plus or minus really, cosine of A times sine of B. So in other words, if I'm adding the angles in here, for the sine formula, I add them here. If I subtract, I subtract. In the cosine formula, oops, I forgot to write the subtraction here, something different happens. When I add here the angles together, I subtract there. When I subtract, I add. So that's not a mistake. You'll see that listed. And the same thing happens in tangent. If I have tangent of an angle A plus B, I add up top, but then when I get to the bottom, I do 1 minus. So you could probably find online some other video that it proves all these, or maybe your math textbook does that. We're just going to work on applying them, all right? And here's how to do it. Cosine of 7 pi over 12 is a difficult problem because it's not on the unit circle. There's no, we got pi over 6, pi over 4, pi over 3, pi over 2. I don't see a 7 pi over 12. So the question becomes, well, where would 7 pi over 12 be? Pi over 12 would be like way down here. So 7 of those, where would that be? Well, 6 pi over 12s would be right here. So 7 pi over 12 must be over here. So when I do my problem, I'm anticipating that I'm going to get a negative answer because I'm in the second quadrant, and that means that this x value would be negative. All right? And so from there, what I'm trying to do is I'm trying to figure out my A and what my B is. Because I want to use this cosine formula. I've got cosine here, I want to use this cosine formula. I think that there's going to be an angle A and an angle B, such that when I add them together, I'll get 7 pi over 12. Now, when I choose A and B, I want those angles to be angles that are on the unit circle so that I can use this formula, right? If I have A on the unit circle, I can evaluate cosine of A. Let's say A was, I don't know, 5 pi over 6. I could just say, oh, great, that's negative square root of 3 over 2, right? So what's A and B going to be? There's a lot of different ways to look at how to figure that out. Some of it could be guess and check, but for me, I can see that it's going to be pi over 4 and pi over 3, right? Pi over 3 and pi over 4. If I add them together, I'm going to end up with 7 pi over 12. And here's why. Pi over 3 plus pi over 4, right? Or pi over 4 plus pi over 3. How would I add them together? I need the same denominator. So this is going to be the same as 4 pi over 12. I just rewrote this one. Multiplied this one by 4 over 4, which gives me 4 pi over 12. This simplifies to this. Plus, this one would become 3 pi over 12. Again, multiply this one times 3 over 3. Now I have the same denominator, and what do you know? I have 7 pi over 12. Great, so these two angles work. Now, if you guessed the wrong angles and didn't get 7 pi over 12, or got something different, make sure you simplify it. Then go look for the different ones. So this is pi over 3, and this is pi over 4, which is perfect, because those two are on the unit circle. So now let's just apply this cosine formula. So this means cosine of 7 pi over 12 is really cosine of, and you wouldn't need to write this out every time, pi over 3 plus pi over 4. Those two are obviously equivalent. I just showed that this is this. So now let's apply the formula. Cosine, what's cosine of pi over 3? Times cosine of pi over 4. And then I'm looking at my formula. I added here, so I'm going to subtract here. I'm just following the formula, plugging it in. Sine of A, so pi over 3, and sine of B, which is pi over 4. Okay? And then from here, what's cosine of pi over 3? Well, let's see. Using the unit circle, cosine of pi over 3 is 1/2. times cosine of pi over 4. Well, that's going to be times square root of 2 over 2 minus sine of pi over 3 is square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. Great. So now I need to multiply all these out. 1 times square root of 2 is square root of 2. This is over 2 times 2 is 4. Square root of 2 over 4 minus square root of 3 times square root of 2 is the square root of 6 over 2 times 2 is 4. Great. So I have the same denominator. This is going to be the square root of 2 minus the square root of 6 all over 4. As I said in the beginning, I would expect this answer to be negative. This looks like it's not negative, but it really is, because the square root of 2 minus the square root of 6, this is a smaller number subtracting a bigger number, so this is going to end up being a negative answer. All right? And that's good enough for now. That is our answer. So the cosine of 7 pi over 12 is the square root of 2 minus the square root of 6 all over 4. That's how you would do those problems. All right, I decided I'm going to do one more of these problems just so that you really understand it. So we've got secant of negative pi over 12. And when I look at my formulas, I just did another problem, I don't have a secant up here. But I do have a cosine. And remember, cosine and secant, they link together. They're reciprocals of each other. So for a moment, I'm going to pretend that I'm asking you the question, what's cosine of negative pi over 12? All right? So I'm going to solve this problem, and then I'm going to get an answer, and then I'm going to take that answer and I'm going to flip it so that it'll be the answer of this. All right? So that's all that I really do. I take cosine of negative pi over 12. So I'm going to need to subtract some angles to get to negative pi over 12. It turns out that the alpha and beta for that is going to be pi over 6 minus pi over 4. And you can verify that using the same method that we did earlier on, right here. So take pi over 6, subtract pi over 4, you'll get negative pi over 12. All right? So now I'm going to do cosine of pi over 6 minus pi over 4, which equals that. All right? So applying the cosine difference formula, I'm going to have cosine of pi over 6 times cosine of pi over 4. And this is where I get the question, shouldn't it be negative pi over 4? No, I'm subtracting the angle pi over 4. So this is my A, this is my B. Subtraction just means I'm taking this angle, subtracting this angle. This is not negative pi over 4. This is not plus negative pi over 4. If it was, you would just have the sum formula, which would work the same thing out. But this is cosine of just straight up pi over 4. Okay, then I'm adding here. Remember the sign switches for cosine there, not for sine. Then we got sine of pi over 6 times sine of pi over 4. Using my unit circle, I'm looking at cosine of pi over 6, and that looks like it's going to be 1/2. I'm sorry, not 1/2. Square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. All right? Plus sine of pi over 6, that's going to be 1/2. Sine of pi over 4 is square root of 2 over 2. Great. And now I'm just going to square root of 3 times square root of 2 is square root of 6 over 4. Plus 1 times 2 is, or square root of 2 is square root of 2. 2 times 2 is 4. And here we go. I've got square root of 6 plus the square root of 2 over 4. Okay? That is the cosine of negative pi over 12. All right? You could check this. You could plug this in your calculator, get a decimal equivalent, and plug this in your calculator, making sure you're in radians, and your decimal equivalents would be, or approximations would be the same. All right? Next one that I have to do, or the next step, sorry. I take that answer. That's for cosine. I need the secant, though. So the secant, because that was my original problem of negative pi over 12, is equal to this flipped. So now I've got 4 over the square root of 6 plus square root of 2. Now, I've taught my students how to rationalize denominators before. This is the answer, but I need to rationalize the denominator. And the first instinct, using the skills that we did before, would be to multiply the top and bottom by the square root of 6 plus the square root of 2. However, that won't work, because when you do that, you'll still end up with square roots on the denominator. And we don't like that. So what I do want to do is I want to multiply the numerator and the denominator by the same thing, so that this is equivalent to 1. by something that's called the conjugate. So it's the square root of 6 minus the square root of 2. Square root of 6 minus the square root of 2. So all I did is I take this sign and I switch it. If this was minus, this would be plus. And when I multiply that out, all the square roots will go away. I can demonstrate that with a little box here. This is what that looks like. So square root of 6, square root of 2, that's from this one. Square root of 6, negative square root of 2. So square root of 6 times the square root of 6 is 6. Square root of 6 times the square root of 2 is a positive square root of 12. Square root of 6 times negative square root of 2 is negative root 12. All right? Negative root 2 times root 2 is negative 2. So this one and this one end up canceling. That's why I did the opposite, right? If this was positive root 2, this would just be two groups of root 12. So I needed this to be negative so that it would cancel out. All right, so now what do we have? It equals, and I'm going to move down here, actually, so that it doesn't interfere with this. We've got on the denominator just 6 minus 2. And on the numerator, I have 4 times square root of 6 minus square root of 2. All right? Now, what does that equal? Well, I've got 4 times square root of 6 minus square root of 2. 6 minus 2 is 4. Guess what cancels? The 4's. So my final answer is the square root of 6 minus the square root of 2. And again, you can check that in your calculator by typing in 1 over cosine of negative pi over 12. You'll get a decimal approximation. Type in the square root of 6, subtract the square root of 2, and you'll get the same decimal approximation to check your answer. That's how you would do the secant. If you had the cotangent, you would have to take tangent, plug in that formula, flip it. If you had cosecant, you'd do the sine, plug in the formula, and then flip it. And the hardest part tends to be the simplifying. That's how you do them. Good luck.